You ever tried to get a powerful AI like ChatGPT to analyze a 100-page PDF sitting on your desktop, only to realize it can't? Or what about your company's latest sales data in a spreadsheet? Well, today we're going to give your AI the superpower to read and understand all of your private documents.
That really is the billion-dollar question, isn't it? These incredible large language models, they've read basically the entire internet, but they have total amnesia when it comes to your world, your files, your documents, your proprietary data. We're about to fix that.
And look, we're not just pulling this out of thin air. Our guide for this whole journey comes straight from the experts at O'Reilly and their fantastic book, Prompt Engineering for Generative AI. We're grabbing the core concepts right from its pages to give you a practical, reliable toolkit.
Okay, so let's start by really digging into the fundamental challenge we're up against, what I like to call the AI's big data problem. Think of it this way. LLMs are trained on this massive but totally static snapshot of the internet. They're like a genius who's read an entire library but is now locked in a room with no new books. They can't see your local files, your private reports, or that new web page you just found. They're living inside a bubble. And this is where LangChain comes in. It is the key that unlocks the door to that room. LangChain is a framework, a whole set of powerful tools designed specifically to break the AI out of its bubble and connect it to all of your external data. It's the bridge between the model's brain and your information. So how do we actually start building that bridge? Well, the very first step is all about data ingestion. We've got to get your data into a format that the AI can actually work with.
So how does this actually work? It really boils down to a simple three-step recipe for making your data AI ready. First, we load it, then we split it, and finally, we store it. Let's break down each of those ingredients.
Step 1. Loading. LangChain has this amazing feature called document loaders. These are basically specialized connectors that can pull in text from pretty much anywhere you can think of. PDFs, spreadsheets, Word docs, websites, you name it. It's like a universal adapter for all your data. All right, so we've loaded our document. Awesome. But now we hit our second problem. Shoving a massive document at an AI is like asking someone to drink from a fire hose. We need to make it digestible. See, the issue here is something called a context window, which is basically the AI's short-term memory. It can only focus on a certain amount of text at one time. A 500-page book? Yeah, that's just way too big. The solution? We use LangChain's text splitters to break that book down into smaller, bite-sized, AI-friendly chunks. Now, you can't just take a butcher's knife to your text. You need a scalpel, and that's where the Recursive Character Text Splitter comes in. It's incredibly smart. It actively looks for natural breaks in the text, like paragraphs first, then sentences, then words. This makes sure you're not cutting a sentence in half and losing all the meaning, which is absolutely crucial for the AI to understand the context.
And to make this really hit home, check out this concrete example from the source material. A 497-page marketing textbook, which is impossible for an LLM to process at once, becomes 737 perfectly sized, digestible text chunks after running it through a text splitter. That's the power of this step right there.
Okay, we've loaded the data, we've split it into these neat, context-aware chunks, but right now, they're just sitting there. How do we make the AI actually do something with them? Well, this is where the chain in LangChain finally comes into play.
The magic behind all of this is a simple but really powerful idea called the LangChain Expression Language, or LCEL. And if you've ever used a command line, you're going to recognize the pipe operator, that little vertical bar. It works just like an assembly line for your AI. The output of one step becomes the input for the next. It's a beautifully simple way to build some seriously complex AI workflows.
So what does this look like in practice? It's actually super logical. You start with a prompt template. Then you pipe that to your language model, and then you pipe the model's raw response to an output parser to clean it all up. Prompt, pipe, model, pipe, parser. It's that simple.
Okay, we have all the ingredients: loading, splitting, and chaining. Now let's cook up something really useful, a summary of a massive document.
I mean, this is the classic use case, right? You've got all those chunks of text from our 500-page book, and you want one single coherent summary of the whole thing. You can't just stuff them all into one prompt. You need a smarter strategy. You need a document chain.
So one way to do it is with what's called a refined chain. It's an iterative process. The AI makes an initial summary of the first chunk, then it looks at the second chunk and refines its summary. It just keeps doing this, building a more and more comprehensive summary with each new piece of text it sees. Another really popular strategy is called MapReduce, and if that sounds familiar, it should. This concept is borrowed straight from the world of big data, used by companies like Google for years. The map step is where the AI creates a separate summary for every single chunk of text, all at the same time. Then, the reduce step takes all those little summaries and combines them into one final master summary. It's a classic, super scalable, divide and conquer approach.
So, which strategy is right for you? Well, here's a quick cheat sheet. First, you've got stuff. That's the brute force method. Simple, one API call, but it only works for really small documents. Then there's refine, which is great for building a detailed summary, but it can be slow because it makes a lot of API calls. MapReduce is the workhorse for huge datasets. It's fast, but you might lose some of the subtle connections between chunks. And finally, map re-rank is kind of the power user option. It's really efficient, but can be a bit more complex to get right. The best choice always depends on your specific needs.
And just like that, you have a complete mental model for teaching an AI to read your personal and proprietary data. Let's just quickly recap the whole journey. It's really just a four-step dance. You load your documents with document loaders, you split them into manageable pieces with text splitters, you build the workflow with a chain using LCEL, and then you execute complex tasks like summarize using smart strategies like MapReduce or refine.
So here's the bottom line. The bubble has been burst. That wall between the AI's general knowledge and your specific information, it's gone. You now have the fundamental building blocks to connect any data source you can think of to the incredible reasoning power of an LLM.
This isn't just theory, it's a practical superpower. So the only question left is, what are you going to use it for? That research archive you've been meaning to get to? Your company's internal wiki? Your personal journal? The possibilities are now wide open. What knowledge will you unlock first?